Geographically, the Indian subcontinent sits directly in the path of the northeasterly trade winds. These winds originate over the massive landmass to the north and blow southwest toward the equator. Because they form over land rather than water, they carry virtually no moisture. By any standard meteorological logic, this constant flow of dry air should have a predictable result. The entire Indian subcontinent should be baked dry, rendered an arid and lifeless desert. But look at the actual landscape. Instead of a desert, we find torrential rivers, deep tropical forests, and massive permanent snowpacks. This contradiction exists because of a seasonal reversal in wind direction. Known as the monsoon, this system functions as a thermodynamic machine, pulling moisture from thousands of miles away to rewrite the geography of the region. The engine relies on permanent geographical hardware. This is the Tropic of Cancer, which splits the country into a tropical south and a subtropical north. To the north, the Himalayas act as a wall 6,000 meters high. This barrier prevents freezing Central Asian winds from ever entering the subcontinent, keeping the region much warmer than other areas at the same latitude. During the summer, a core rule of physics takes over. Land masses heat up significantly faster than the surrounding oceans. As solar radiation intensifies, it superheats the Tibetan Plateau and the northern Indian plains. This heat causes the air to rise rapidly, creating a massive atmospheric void. This results in a continuous low-pressure zone hovering over the entire landmass. This pressure differential between the scorching land and the cooler oceans prepares the engine to pull in weather from thousands of miles away. To fill that low-pressure void, nature pulls high-pressure air from the distant southern Indian Ocean. As these winds cross the equator, the rotation of the Earth applies the Coriolis force, causing the northward winds to bend sharply to the right. The curving winds travel over warm oceans, scooping up vast moisture before slamming into the Indian coastline. High above, summer jet streams shift position, moving north of the Himalayas to allow the monsoon to advance across the peninsula. At the same time, the intertropical convergence zone, a belt of low pressure, migrates northward, dragging heavy rain bands directly across the northern plains. These combined forces transform simple heat into a delivery system that carries billions of tons of water across the continent. By October, as the sun moves south, the thermal pressure reverses. The monsoon winds begin to withdraw, and the low-pressure zone migrates into the Bay of Bengal. This transition leaves the land moist, while temperatures remain high, creating an oppressive period known as October heat. This pressure shift also triggers violent tropical cyclones in the Bay of Bengal. These storms frequently strike the eastern coasts, causing widespread damage. The engine distributes its water with total inequality. While parts of the northeast receive over 400 centimeters of rain, regions in the west get less than 10. The atmospheric machine is indifferent to geography, creating a landscape of stark climatic extremes. These arrival dates are highly specific, dictating the exact farming and economic schedules for millions of people across the subcontinent. This rhythm has forced deep human adaptation. It defines the architecture of the country, from stilted houses in the flood-prone east to flat roofs in the dry west. It brings a cycle of floods and droughts and creates immense regional contrasts. But in doing so, it ties every person on the subcontinent to the same rhythmic cycle, dictated by the atmosphere itself.